Protein assay is a method to determine concentrations of protein solutions. It usually involves a UV visible domain, so a nanometer of 200 to 700 maximum. There are two possible approaches. One is directly you can put it through the protein sample, about 220 nanometers is usually absorbed because the aromatic rings in them. Or the other possibility is you can add a colored dye to the protein and make them colored, and then we change their concentration and measure how much of light is being absorbed. Uh, then in either case we have to produce a calibration curve, but before that let's just look at absorptions of hemoglobin. For example, when it's put through UV visible, this is what happens. A wavelength of 220 and a wavelength of 400 is absorbed, and what you see is usually the color that is not absorbed. So in this case you are going to see between 600 to 700, and you're going to see the red of the hemoglobin. So the other two wavelengths are absorbed, and the red is the color that you see that has not been absorbed. Now what the setup is usually, this is the schematic of the setup, and you probably have used a spectroscope in your lab. We usually use a cuvette, a holder to put our samples in it, and then a wavelength of a specific wave goes through. So in case of protein it's about 220 nanometers, and this is the initial intensity of the light going through. And depending on concentration, some of this light is absorbed and another wavelength comes out of that, and that's your eye in this case. This is known as Beer-Lambert law, and the equation is given to you in data booklet. So I0 is the intensity that goes through, I is the intensity that comes out, and base 10 of this log is equal to A, which is your absorbance. Now this is also equal to a series of constants. The first one is molar absorptivity constant, which is specific for each solution. C is the concentration. At beginning we know our concentrations, gradually we want to know the concentration of unknown. And L is the length of this cuvette or sample holder, which is usually 1 centimeter. So this equation you have in order to calculate things or be able to say the unknown. Usually two of these variables are given, the next one you have to be able to produce. Now when we have a sample of protein, what we like to do is first make our own known concentrations of different concentrations of that protein. For example, we might have 1 milligram per decimeter cube, then 2 and 3. We put it through the instrument and we measure their absorbance. Then finally we have a graph of absorbance versus concentration. And also remember, the concentration should not be large. After a while, if this gets really concentrated, the graph is not linear anymore and it tends to have a curvature. So we want it to be at low concentration. Finally, once we have this calibration curve, then the question could be that the absorbance is given. For example, if it's 0.29, on your calibration curve you are going to go to the line and interpolate and come down here and read the concentration of unknown. In this case, for example, this will be 3.6 parts per million. So to do protein assay, we use UV visible light, and you need to be able to use this equation, Beer-Lambert, or be able to look at a graph of calibration and guesstimate what is the concentration of unknown protein.